It's good to have you back on CrunchEconometrix. This is the fourth of 9 GMM video series. I appreciate those who gave feedbacks on the first 3 videos, and I'm happy to hear that your confidence levels have increased with respect to estimating GMM models. If you have not watched the first 3 videos, please do so in order to get the basic understanding. I will encourage you to keep sharing my videos with your students, colleagues, and academic community on social media. Let them know that CrunchEconometrix is dedicated to beginners and intermediate users. To estimate the One-Step System GMM, I have listed on the screen a 10-point preparatory guide. Endeavor to have a panel data. It may be balanced or unbalanced. Ensure that the number of cross-sections is greater than the time dimension, and remember to generate ear dummies. Specify a dynamic model, auto-regressive in nature. Set up Stata to run panel data estimations. Remember to have your do file and your log file on. Perform some preliminaries as the case may be. Estimate the model, check for diagnostics, and finally interpret your results. In this example, I have a balanced panel. I have 54 countries across 11 years. I have specified a dynamic model, dynamic in the sense that it contains the lag of the dependent variable as a regressor. I have set up Stata and I have my do file ready with all the codes written. I also have my log file on to track all estimations. It is assumed that I have done all the necessary preliminaries. So what I'm going to show you in this video is how to estimate the model, run several simulations, and we check diagnostics as we go along. I will not be interpreting results in this video because I have a different video for that. Please let me mention here that you have to use your own data set. You will not have access to my data, but the do file will be available on my website. So please load your own data and just practice along with me. This is the One-Step System GMM specification in Stata. You can see a sub-option here, equation level. I will explain about this more on the next slide. I want to also state here again that the system GMM is the augmented estimator. How? One equation is expressed in levels form with differences as the instruments, and the second equation is expressed in first difference form with levels as instruments. On the screen are 2 codes that you can use to estimate the One-Step System GMM. In the first code, we have the sub-option equation level, and in the second code, the sub-option equation level is omitted. The popular opinion is that the first code is what Arellano-Bova and Blundell-Bond actually simulated by using the first difference instruments for the level equation and the level instruments for the first difference equation. So technically, if you are using the first code, you are simply telling Stata to use more instruments than what we'll have obtained if you are using the second code. Now let's take a look at the second code. Stata will still return a system GMM results simply because you have removed the no level equation from the option here. So by default, if you run this second code, Stata will turn out a system GMM results for you. But the moment you indicate no level equation in the options here, you are going to get a difference GMM results. So let me quickly explain the options listed here. The no diff Sargan option prevents Stata from reporting certain difference in Sargan and Hansen statistics. The robust option will provide a heteroscedastic and autocorrelation consistent variance-covariance matrix. By using the orthogonal option, you are requesting that the forward orthogonal deviation transformation be used instead of first differencing. And by indicating the small option, you are telling Stata that you prefer to have T statistics and F statistics and not Z or wall test. I also have a note here that says that opinions actually differ as to which of these codes should be applied for system GMM. Some will say use the first code. Another school of thought will say any code is okay. This is because the results are not significantly different from one another. Let's take a look at the classification of regressors in system GMM. There are 3 categories. We have predetermined regressors that are assumed to be correlated with past errors but not with current and future errors. We have endogenous regressors that are correlated with the past and possibly the present error terms. We also have strictly exogenous variables. These are not correlated with errors in all the temporal periods. Once again, please use your own data. You won't have access to my data, but you will definitely have access to my do file, and all the do files I've used in my Stata videos. They are all on my website. So why use Hexagon 2 and not the Hexagon command? Remember, there are two estimators. The original estimator is often referred to as the difference GMM, while the augmented estimator is known as the system GMM. Hexagon 2 implements both estimators. It also makes available a finite sample correction to the Windmeijer 2000 two-step covariance matrix. Hexagon 2 makes two-step robust more efficient than one-step robust. It also addresses the instrument's proliferation problem, especially when you use it with the collapse option. So why do you estimate a one-step system GMM? Remember, it is simply the augmented one-step difference GMM. It uses more moment conditions than the one-step difference GMM. It is also efficient and robust to heteroscedasticity and autocorrelation. What will be the learning outcome in this video? We are going to run about 13 simulations, and I'm going to show you the impact of these options on your results. You can see all the options I've listed here. And these are the classes of the variables in the model. We have the dependent variable has a log of GDP. The endogenous variable is the log of GDP. I have 3 explanatory variables and I have 3 control variables. In my instrument set, you can see the instruments are listed. I have an internal instrument, the log of GDP. And in the course of the video, I'm going to make another assumption by making mobile a predetermined variable. And by being a predetermined variable, I have to remove it from the exogenous instrument set and put it in the GMM instrument set, making it an endogenous variable. So I will also show you how this will affect your result as we go along. I have external instruments here, and in the course of the simulation, I'm going to show you how your results can change when you include additional instruments. If you are ready, please load your data and let's get started. So we are now in Stata domain. You can see my log file is on to track all I'm going to do. This is my data editor. Like I said, I have 54 countries. The first country is Algeria and the 54th country is Zimbabwe. Each country has 11 years observations, as you can see, from 2005 to 2015. And I generated 11-year dummies to capture the time variations across the years and across the countries. So please make sure you have your year dummies generated before you run any GMM estimation procedure. It's very, very important. Here is my do file with all the codes for the one-step system GMM. This do file will be made available on my website. Same with all the do files for all my Stata tutorials. But make sure that you have a Google account and a Chrome browser for easy access to the files. I have already executed all this command, which I've tracked in my log file. So analysis and explanation will be conducted from my log file. So here is the log file, which has tracked all the estimations. So let us proceed with the explanation. Like I mentioned before, we are running 13 simulations. So let's get started with the first one. In the first simulation, we are going to use the sub-equation command, but without the collapse option. So let's see how the result will turn out. This is the code which I've executed. You can see here I have the equation level option, which is the sub option, and I'm not using the collapse command. Let's take a look at the result. At the top of the table, you have the one-step system GMM. So this one tells you you have the right estimator. Because we are not using the collapse option, the number of instruments is greater than the number of groups. The lagged dependent variable is significant at the 1% level. And I also have my key regressor, which is mobile, also significant at the 1% level, but that is not where we are going. Let's take a look at Hansen. Hansen is 0.924. This is not good at all. This is not a good model. I have a little note here that says that because Hansen is 0.924, it indicates too many instruments and the model is not good. So how do we correct this? Let us run the second simulation, still using the sub-equation option, but now we are using the collapse option. So this is what we executed. You can see it here. You can see the collapse option here, and we have the sub-option equation level. Let's check out the results and see whether it's different. At the top of the table, you can see it's still One-Step System GMM. Now the number of instruments is now collapsed 25, which is lower than the number of groups. Let's check out the regressors. The lagged dependent variable is still significant at 1% level, while mobile has reduced in significance to 10%. Let's look at Hansen. Hansen is 0.051. This is very, very tricky. You may decide not to reject the null at the 5% level because this is just slightly above the 5% level. But if I'm to use this model, I will not take this result. So this one tells me my instrument set is not good. And that is what I wrote here. With Hansen at 0.051, instrument set is not good. So we must find a way to improve this model. I may decide to change some variables or even include some instruments just to improve the Hansen statistic. Let's look at the third simulation. Now we are going to remove the sub-equation option and also remove the collapse option and see the results. This is the code we're executing. You can see the sub-option equation level is not here, and we are not using the collapse option. Let's take a look at the results. By now you should know that without the collapse option, your instrument set will be increased. The number of instruments will be increased. You can see it, not surprising, higher than the number of groups. Let's take a look at some of our coefficients. The lagged regressor is still significant, and the mobile, surprisingly, is now so significant at 1% level, even with the proliferated instruments. Let's look at Hansen 0.932. Definitely not good. Okay, simulation 4, without equation sub-option but with the collapse option. When that command was executed, Stata returned this error message for me, which says that equation is not identified because my regressors outnumber instruments. So if I'm very particular about this model, what will I do? Number one, I'll have to look at my regressors and reduce them or change them as the case may be. Run other simulations and come up with something. So I will have to just address this error message if I'm particular about executing this model. Let's look at simulation 5. I'm going to show you how your results change given the assumptions you make concerning the classification of regressors. Remember, all this while I've been treating mobile, the log of mobile, as an exogenous variable, and by being an exogenous variable, it has always been in the IV style instrument set. But now I want to make an assumption that mobile is a predetermined variable. That is, I'm assuming that it is correlated with past but not with current and future errors. And predetermined variables are included in the GMM instrument set. So this is the command I am executing, now using the log of mobile as a predetermined variable and is now included in my GMM set. I'm also using the equation level sub option and I'm using the collapse option. So let's look at the results. Because we are using the collapse option, instrument set is reduced to 35, which is lower than number of groups. That is good. If you take a look at the regressors, none of them is significant. This is not good at all. Only the lagged dependent variable is significant. Let's go to Hansen and see what we have. Hansen is at 0.075. Well, this is a bit okay because you can decide to say that instruments are valid at the 5% level. You can say that, which is what I wrote here. Because Hansen is this, we cannot reject instrument validity at the 5% significance level. So you may decide to accept this result at the 5% significance level. But if I were you, I will not accept this result. Basically because none of my coefficients, none is significant. So I won't take this result. Let's look at simulation 6. Still treating the log of mobile as a predetermined variable. Now we are going to run this command without the sub option of equation level and still using the collapse option. So what do we have? With the collapse option, instrument set is reduced to 35. Let's take a look at some of the regressors. Now I have mobile significance at the 10% level. This is fair enough compared with what I had before. Let's take a look at Hansen. Hansen is 0.183. So this one tells me my instruments are valid. I may decide to take this result. At least I have a significant coefficient apart from the lagged dependent variable. Simulation 7, we are going to execute this code without the no diff Sargan and collapse option. So this is the code we're estimating. I have removed the no diff Sargan and there is no collapse option. Still using the log of mobile as a predetermined variable. What do we have? Because we are not using the collapse option, instrument set is over-bloated to 132. Surprisingly, we have two regressors, very significant, mobile at 1% and FTS at 5%. But let's take a look at Hansen. Hansen is 1.000. Because we removed the no diff Sargan option, Stata will report to you the difference in Hansen test of exogeneity. So if you want to have this report, you know what to do. So because we didn't use the collapse option, we can see that Hansen is 1.0, which tells you clearly that your instruments are not valid. So don't even bother using this result. Just discard it. Simulation 8. Now let's execute without the no diff Sargan but with collapse option. So this is the command. There is no diff Sargan and we are using the collapse. What do we have? From here you can see instrument is reduced to 35, which is lower than the number of groups. Let's take a look at the regressor. Apart from the lag dependent variable, mobile is significant at the 10% level and Hansen is 0.183, while you also have the difference in Hansen's test of exogeneity reported. Let's take a look at simulation 9 without robust option. Remember that the robust option will provide a heteroscedastic and autocorrelation consistent variance covariance matrix. And this is the code that has been executed. We are using the collapse option, but we are not using the robust option. So what do we have? You will observe, if you compare what we had before with the results, we now have our standard errors are lower, but the t statistics are bloated. So when you don't use your robust option, you are likely to have inflated t statistics. So be careful to always specify robust option whenever you are estimating the GMM model. And you can even see here that the Hansen statistic is not reported, but the Sargan statistic is reported and is very significant at 1% level, which indicates that your instrument sets are not good. And I have a small note here that says when you don't use your robust option, you will observe that your coefficients are the same, standard errors are reduced, but the t statistics are inflated. So next we are going to simulate without the orthogonal option. Remember that the orthogonal option requests the forward orthogonal deviations transformation be used instead of forced differencing. So this is the code that we have executed. You can see here that we have removed the orthogonal option, but we are using collapse. And this is our result. Instrument set is 35 because of the collapse option that we have indicated. But because we are removed the orthogonal option, Stata is now using instrument for forced differences equation rather than the forward orthogonal deviations transformation. You may not notice a reduction in your number of observations if you have a balanced panel, but if you have an unbalanced panel and you removed the orthogonal option, you are likely going to suffer some loss of observations. So to be on the safer side, it's always good for you to specify the orthogonal option when you are running your GMM model. Let's take a look at Hansen. Hansen is okay at 0.287. You can see I wrote here, you may lose more observations if your panel is unbalanced. So always indicate orthogonal option. Simulation 11 without small option. The small option is telling Stata to produce T statistics and F statistics and not Z or Y statistics. So if you remove the small option, this is the syntax. By removing the small option, Stata is reporting the Z statistic and the world statistic instead of T and F. It's a matter of preference, it's a matter of choice. I, for one, prefer the T and F statistics because I'm used to their interpretations. Simulation 12, let's look at how results can change by increasing the exogenous instrument sets with one instrument. So now I'm going to use inflation as an exogenous instrument. I've not been using inflation before. You can see inflation is here now as an additional instrument. So what is the outcome? Instrument set is now increased from 35 to 37, as you can see here. By using inflation as an additional instrument, you can see here the inflation coefficient here is significant at the 1% level. Mobile is also significant at 10%. So that means inflation is a good instrument for my model. Let's look at Hansen. Hansen is also good at 0.142. So I can say that by including inflation in this model, some coefficients have improved in statistical significance, and Hansen statistics shows that the instruments are valid. So the last simulation is to show you how your results can also change when you use a variable that is not in your model as an additional instrument. So now I'm going to include the log of trade as an additional instrument. So this is the syntax. And here you have the log of trade, which is not in my model at all, but Stata allows you to do that. You can pick any variable in your data set to use as an instrument. So this is the outcome. Because of the collapse command and the additional instrument set is now 36, which is still lower than number of groups. Using trade as an instrument, well, my mobile coefficient is significant at a 10% level, and Hansen is also okay at 0.219. So I can say that using the log of trade is not bad as an additional instrument, even though I would have preferred to use only inflation. But it's not bad at all. So here you can see that using a different variable that is not even in your model can actually improve your regression or estimate, as the case may be. But if you do that in your own data and you see that your results are not good, just remove it and use something else. I will always encourage you to please read up papers, articles, and look at those that use the system GMM to estimate their model. I have some papers here on the screen for you. My paper is there listed as number 4. You can check it out, and there are other several papers available on the internet. Please always read up. Video tutorials are not sufficient enough. They are just to guide you. You need to do little reading to support your understanding. Please stay with me. The next video will be on two-step system GMM. It's been wonderful having you. Thank you for watching. Thank you for sharing my videos. If you have not subscribed to my channel, please do so. CrunchEconometrix is dedicated to beginners and intermediate users. Please join my Facebook community. Join me on Reddit. Join me on Twitter. Please don't go away. I'll be right back with the two-step system GMM.